We can see 95% of teens use YouTube, 67% use TikTok, 62% use Instagram, as well as 59% use Snapchat as of 2023. This is extremely urgent. TikTok specifically took rise in 2019 due to COVID. With COVID-19, everybody was at home, everybody was bored, and then TikTok introduced short-form social media content, to which it ended up dominating social media as well as teen usage. After that, all these other social media platforms followed, producing the same short-form social media video content. However, teens are extremely vulnerable in their forms of adolescence due to high gray matter content in the brain, indicating senses of neuroplasticity, which is the constant neural rewiring of the brain, as well as synaptic pruning, where you are constantly rewiring your brain and refining core functions. This leads to low impulse control due to the high content of gray matter while watching short-form social media content. So short-form social media content provides rapid bursts of audio and visual content. You're able to like, you're able to follow, you're able to scroll whenever you're bored to have this media be as addicting as possible because it's engineered to make as much money as possible. This leads to a negative feedback loop, which can be associated with drug use, as you're constantly picking up your phone to use this addicting media. Looking at the disparity between the limbic reward system, which is your dopamine response, as well as the prefrontal cortex, the disparity in maturation, as we see the limbic system matures around ages 10 to 13, while we have the prefrontal cortex ages around 20 years old. This disparity leads to changes in impulse control, focus, goal pursuit, as well as decision-making processes during adolescence, which in the end leads to frequent multitasking, fragmented attention, sustained focus, losses in memory, and as well as losses in working memory capacity. So neuroelectrical activity is what your brain is constantly producing as you go throughout your day, as you have around 86 billion neurons. We can see over here, we have different waves within the brain, where the higher the frequency, the more focus is indicated. This is the basis of how you think, which is neurocommunication. And the biggest part of this is that these brainwaves are specific, reproducible, as well as recordable. Recordable by using an EEG, which stands for electroencephalography, is a non-invasive headset which can be put on the brain, completely safe, and is able to get information from the prefrontal cortex and other areas of the brain. So for this experiment, I used the Unicorn Hybrid Black, which is an electroencephalogram, where there are 8 different electrodes on the headset, which act as little magnets, which are able to successfully record neural electrical data. It's also able to record the P300 wave, which I will get to. Looking at my literature review, we can see supported by Chiosi et al., specifically looking at TikTok, which indicated the first content of short-form social media videos, had the highest decrease in prospective memory tasks. So this shows it's not simply screen time itself that is detrimental to attention spans, but is specifically short-form social media video content. Looking at Versberg and Conrad, they actually used Unicorn Hybrid Black, which is what I used for this experiment, and they saw, looking at theta as well as alpha waves, we saw changes in that measure attentional drift using Unicorn Hybrid Black, which indicates a correlation with my experiment. And then looking at the P300 wave that I discussed earlier, we have over here a big spike in brainwave analysis. We could see regular users versus heavy users. The P300 wave is the big spike, the visible spike that you can see, and this indicates the decision-making process in the brain, as well as a decrease in attention and working memory. But this raises the question, what are the immediate effects of watching short-form social media content versus heavy users who indicate this extreme disparity in the P300 wave? So this leads to the gap in the middle of my research, where I'm looking at people's personalized short-form video content whether they use Instagram, whether they use YouTube, whichever is personalized to where they have their For You page, which they like the most, which is, again, as addicting as possible. And what are the immediate effects as soon as you put down the phone? How is that going to impact learning? How is that going to impact attention and memory? I expect to have an increase in theta waves, an increase in alpha activity, as well as a decrease in beta and P300 wave response, which indicate as I stated. So for this experiment, we had 30 adolescents, 20 male and 10 female, who were recruited through Pawling Center School District, as well as others in the community. And we had consent as well as IRB approval. Participants were then assigned anonymous numbers for the experiment, and here we can see the setting. We have stable lighting, minimal noise. We're looking at this white projector screen to have as little noise as possible, because that is a limitation of using the EEG. Because it is a more inexpensive version, it is prone to noise, so we're trying to keep it as quiet with as little noise as possible. So when the participant would first come in, they would fill out a Google form indicating sorts of demographics. After this form was filled out, we would put on the EEG cap and inject a gel solution. This solution is able to increase conductivity in these electrodes, which again act as magnets to limit noise. After the headset was put on, they would go through their first task, which is all in counterbalance order. So after the headset was put on, we'd have 2 5-minute sessions. This would either be a short-form video session where they would watch their personalized short-form social media for 5 minutes, and then they would complete 2 different tasks. Or they would complete a calm meditative task, which is a 5-minute video, and then complete the same tasks. In between, we would have a 2-minute acquisition period to receive a baseline and EEG recording. Looking at these tasks, we can see the EEG is constantly recording electrical activity. And then the first task over here where we see incongruent and congruent trials, this is called a Stroop task, which is able to see attentional drift. What you're supposed to do is say the colors, as we can see on the congruent trials, the colors and the words are the same, versus in the incongruent trials, they are flipped. The word recall task would have 15 different words displayed, and then after a minute of time, you would write down as many words as possible. Accuracy and time were recorded for each, as well as intrusion count, where an intrusion in the memory recall task is a word that the person made up and was actually not listed. So after this, we end the EEG recording, and then we have a post-exposure survey. The participant in the post-exposure survey would rate different conditions such as fatigue, mind wandering, etc. This is prone to bias as we have limited participants. To analyze data, Brainwave Analyst was used, which is able to take into account hundreds of thousands of different artifacts and kind of find a culmination and find key forms of key statistics. And we can see, because it was continuously filtered, we were able to find major changes, major gaps, looking at the different power spectral densities, which again are the different types of waves ranging from theta to beta. Taking this into account, looking at my results, we can see comparing the congruent and incongruent trials where the blue is the control video, so this is the meditative task, versus the short form, the orange, we can see a major disparity specifically in incongruent trials, indicating potential drift and impairing executive function. This is again immediate slowdown immediately after watching the short form social media video versus immediately after watching the calm control video. Looking at the accuracy of these colored Stroop tasks, we can also see disparity specifically in the incongruent trials, which require the most attentional use. We can see the disparity in accuracy, which also indicates immediate response after scrolling. Looking at the word recall task, we saw the increase in intrusions, which again are the words that they made up, as well as a major disparity in words recalled. We can see a decrease immediately after watching the short form social media content. Looking at the core of my project, as supported by my hypothesis, we could see, looking at theta, alpha, beta, and the theta-beta ratio, we had successfully measured a decrease in attention as well as mind wandering, which indicates disengagement. This is supported by a change in increased theta, increased alpha, decreased beta, and increased theta to beta ratio, which is just comparing the two theta beta subjects. And these, again, are markers of disengagement, cognitive overload, and attentional drift. So now looking at the self-report ratings immediately after watching the videos, you would complete the survey at the end. And although this again is prone to bias, participants did indicate a decrease in focus, increase in mind wandering, increase in fatigue, as well as increase in mind wandering, increase in mental journeying capabilities. And looking at the P300 amplitude, this is especially interesting because we saw a similar decrease after watching the short form social media video towards that heavy users, which indicates a similarity between immediately putting your phone down, your brain state immediately after watching the short form social media video, versus as a heavy user. So you're going to have the same immediate response in neuroelectrical activity as a heavy user, versus immediately after watching short form social media videos, which is especially influential in adolescence. Taking all this into account, the Unicorn Hybrid Black, in fact, was extremely feasible and successfully was able to measure differences in cognition and neuroelectrical activity. As we saw, increased theta, increased alpha, and decreased beta to beta ratio, which indicates mind wandering, low task engagement, executive control, cognitive load, and decreases in short form memory. And in the future, I would love to look at the changes between specific social media sites, which is going to be the most impactful, and then how can we reverse and how can we go against this? How can we use this knowledge to then say, what next steps can we take to counteract this, especially in the schooling system? Because this project indicates that immediately after watching a short form social media video, like TikTok, for example, you're going to have similar cognition to that of a heavy addicted user, which is extremely influential in learning. I'd like to thank my mentor, Mr. Harrison Canning, as well as my science research peers, and Ms. Jillian Ronaldo, my wonderful science research teacher. Here are my references. Thank you for listening. I'll leave it off to Anthony. Any questions?